Trevor, super happy that I got you in here, drug you down here to meet.
Me too.
I've regarded you as my mentor for basically my whole mechanical race car engineering life. Just wanted to chat through kind of what your inspirations were, your projects, and kind of how that led me down my path. I met you working for the Volkswagen program, which was run by the RCO family. Early in my career, I just graduated college, and I was hired as the CAD guy in-house, and you were basically consulting and talking me through the development of a race truck for VW, and we got to work together basically turning all of your 2D hand sketches into a computer model. And I think early on you challenged me really to understand the geometry before you just start designing. And now that has become really one of my fundamental critical things. When you and I were talking about, when someone asks you, how do you design a whole car, where do you start? And for you, that's not particularly troubling.
You mentioned something. One thing that's really important as far as being a designer of, I think, complete systems goes. Cars are a system, a complete system, complex. They include mechanical components, aerodynamic components, fluid issues. You run into a whole lot of disciplines. And you've got to really be interested, in a way, in an awful lot of disciplines to effectively design a complete car. Everything you design starts out in the cranium, unfortunately. And the more you can cram into your cranium that you can work with mentally all at once, the more useful you can be in the business you're in.
The thing that's so interesting and different about our two paths is that you started designing cars before the era of computer-aided design. And when I really got into car design, I was well into my computer-aided design experience.
Lucky you.
Lucky me. You've even mentioned that you conceptualize things a lot further down the road in your mind before you start drawing and building. I remember the first time I went to your house, one of the most fascinating things was the cabinet you have in your entry, which is basically all of your proof, maybe not all, but a lot of your proof of concepts for continuously variable drives and articulating joints and everything else. And one of the most fascinating ones that you and I spent some years going down this road together is this lovely mechanical proof of concept model that you did. This entirely handmade in your garage, essentially with a bandsaw and a lathe. And it's just a testament to your ability to conceptualize in your head and to manufacture items by hand precisely. This is something that's very rarely seen, especially nowadays with computer design and 3D printing. Most people don't handcraft.
So, making this model, which required basically 3 identical pairs of components mounted on 2 identical rotating pieces, was a kind of an interesting challenge and a lot of fun, but it yielded a proof of concept device, a universal joint in particular, and more in particular, what's called a constant velocity universal joint, that doesn't exist except here. So that's cool. But the next step took several years, and that's where you came in to this constant velocity project.
We have that model too.
Because
that's this version.
What you did was to commit everything I had done on pencil drawings and construction of a physical device. You committed everything to CAD, and and did a really good job of it. And the great thing about CAD is that if you do it right, you can have a device that basically can move, rotate. You can collect data from the device as it's, for instance, rotating in space to prove that it does what you might claim it would do. So you did a great job working with me for several years to go from this joint that wasn't as strong as I wanted it to be to this joint, which hopefully is visible here. We have a much larger, more visible variation of it here. And why don't you hold it and talk about it a little bit? But the ability of this unit, the unit I built by hand, to take twisting forces for a given size is way less than what we finally came up with for doing essentially the same thing. But this final unit can handle a lot more twisting force than the original unit, and it took years of hard work to actually come up with it. It's hard to overstress the necessity for just knowing a lot of basic things about a lot of basic disciplines that are totally disconnected from each other, like hydraulics, aerodynamics, physical characteristics of materials, to have a feeling knowledge of materials, I think, to know, to have felt different grades of aluminum and to have bent them with your hands and have a feeling for stiffness differences. And then steel, same thing. There's something about tactile information, I think, that's extremely useful when you get, for some reason, just right down to cases, having a feel for materials. Temperature, heat transfer issues, we deal with that in radiator cooling systems. And when you're designing a race car, you're trying to optimize all the weights everywhere. If you got a radiator somewhere, it's a good idea, if you have air flowing into the radiator, it's a good idea to know the best way to get it out and where to put it and where not to put the output. So, and that requires knowing something about aerodynamic pressure differentials and where they might, what they might be where on a vehicle. And anyway, it's a fun business, partly because you're playing games with so many variables at the same time, so many variables related to different disciplines all at once.
And I think that the ability for you to take into consideration all of these different areas, all these different aspects you need to consider is almost subconscious. It almost is for me. I think it's that you've been looking at different things for so long, and your brain just knows which path to go down.
You regard me as a mentor, and I really appreciate that. But one of the great things about you is, one of many great things, is you're one of the last of the Mohicans in a certain area, and that is there aren't too many people today that actually take on the job of designing whole vehicles from scratch. Not too many. And for the number that there are even fewer that have actually built every component on a race car themselves. And you fall into that category. And I did too. I think there's something extremely useful about hands-on, being able to build parts. If you're going to be a good designer, you got to know how the machinery works that makes the parts, because that has a lot to do with designing a part that can actually be built. You're really good at that because you know how everything works to get parts built.
I think the reason we became friends is because we have a childhood fascination with mechanical things and talking through mechanical things and feeding off of one another in terms of working towards a mechanical goal. I think both of us, aside from seeing one another as a tool to go down that path, I think the amount of carnal joy we get out of talking through those processes is probably what made us friends.
And that's kind of the basis. That's a good basis for good friendship. We love to do the same things. We like to talk about some of the same things in some of the same ways. We can each learn from each other, and that's good. It's been great.
Trevor, I wanted to thank you very much for coming down and chatting through our past and all the different stuff we've done over the years, that you've done over the years, and looking forward to more projects.
Lots of fun. So am I. I think we're both involved in some pretty interesting projects right now, so that's good.
Yep, keep them coming.
They don't stop. Don't ever stop.
Nope.
Even at age 84, don't stop.